Hi, in this video, we want to look at the concept of inverse functions and also the largest possible domain of functions. In the previous videos, we've looked at the meaning of mapping and function. We've also talked about composites and function. But what does it mean when we talk about inverse function? First and foremost, a function will have an inverse if it is one-to-one and then if it is an onto function. What do I mean? Previously, we said we have two types of mappings that classify as function. That is the one-to-one mapping and the many-to-one mapping. So let's say we have this. Let's say we have this. Okay, and then there's two. So we know this will be one-to-one if every element of X or the input maps out to a unique element of the output. So this is one-to-one. I'm now saying for a function to have an inverse, first of all, it must be one-to-one that looks like this, and then it must be onto. So what do we mean by onto? That is, if you take what's it called? If we assume this becomes the inputs this time around, all the element of the output are they mapping out to a single element in the input also? Then definitely, if that is true, we say the mapping is onto. I repeat myself. We already know what is one-to-one. If each input has a unique output, that is, one input is not mapping out to multiple outputs, or two inputs are not mapping out to the same output. One input, one output, one input, one output. For it to be onto, now think about the output as the input. Now go back the same way you're coming from. Is it also one-to-one? The reverse way. If it is also one-to-one, then we say it is onto or subjective. Now, for a function to have an inverse, it has to be onto and also one-to-one. So we're saying that for a many-to-one, so this maps out to this maps out to this also. In as much as this can be called a function, we can't look for its inverse because by the time we're going the other way, if this now becomes my input, you can see it is mapping out to many outputs. So this is not one-to-one, neither is it what? Onto. All right. Now let me try and do something like this. So let's say we have 1, 2, 3, 4, and here I'm having okay, 2, 3, 4, 5. Okay, so let me try and bring this down a bit. Okay, so let's say we have again. So 1, 2, 3, and 4. So I want this to be a bit bigger. So 2, 3, 4, 5, 6, and 7. And then I'm saying 1 is mapping out to 2, 2 is mapping out to 3, 3 is mapping out to 4, 4 is mapping out to 5. All right. So is this a one-to-one function? Yes, this is a one-to-one function. But is it onto? Definitely not. You can say 1 is mapping out to 2, 2 is mapping out to 3, 4 is mapping out to 4, 4 is mapping out to 5. But when we come back the same way, you can see that 2, 3, 4, 5 are the only ones mapping out to these inputs. 6 and 7 have no input. So we can't say this is what an onto type of function. So this doesn't have what's it called? This doesn't have an inverse either. Now this domain part, if I were to mention the members of my codomain, I'm going to be mentioning 2, 3, 4, 5, 6, and 7. But if I was to be mentioning the range, if my codomain CD is given as 2, 3, 4, 5, 6, and 7, this is my codomain. My range now will simply be what has an image in the input, that is 2, 3, 4, and 5. So this is the difference between our codomain and then also the range. Now let's look at how we can now find the inverse of a function. We already said for a function to have an inverse, then it must be one-to-one and also it must be an onto function. So let's say we're given our first example. and then we're being asked to find the inverse of the function. So let's take let's say we're given f of x to be equal to 2x plus 3. This is question 1. For question 2, let's say we're given, okay, so we've used f of x, let's use h of x is equal to x squared over 4. All right, so for the first one, so we have two methods of finding inverse. Two methods. The first method only works for linear relationship. That is when we have a single x. The first method doesn't work when we have multiple x's. So for the first method, we look at the last thing we did to our function or to our rule. What do I mean by that? Remember, when we're determining this rule, we looked at what we're doing to a particular number to get the output. So at first, for this number, let's assume that x is equal to 1. When I'm putting an input of 1 inside of this function, at first I'll be multiplying by 2, and then lastly, I'll be adding 3 to it. So if we're looking for the inverse of the function, then I'll do the last thing that I did to the rule. The last thing I did to the rule is the first thing I'm going to do. But this time around, I'll do the opposite. So you can see that the last thing I did was to add 3. Then the first thing I will do is to do the opposite of the last thing I've done. So for instance, I've added 3 to x. So the solution for number 1, I'm subtracting 3 from x. So I will simply say x minus 3. So if x minus 3, and then what's the second thing I did, or the first thing I did when I was coming to attach my rule? So you can say I multiply by 2, then I have to divide by 2. So let's test this whether it works. So let's input 1. So if I were to put 1 here, so 2 in the bracket of 1 plus 3. So 2 times 1 is 2 plus 3, that will give me 5. So definitely, if I want to take this 5 back to give me 1, this input, so let me put 5 here. So 5 minus 3 over 2. So 5 minus 3 gives me 2. 2 divided by 2 is equal to 1. So you can see that I'm back where I started from. So this is one way in which you can find the inverse of a function. Now, if this is too much for you to handle, then the second method is there. For the second method, you write f of x as equal to y. So f of x. So the first thing you want to do is to say f of x is equal to y. That is, anywhere you see f of x, you can indirectly write y. And remember, f of x is already equal to 2x plus 3. So I can simply say y is also equal to 2x plus 3. Now, after I've written this, then anywhere I see y, I want to write x. Anywhere I see x, I want to write y. So I'll do it in such a way that this x equal to 2y plus 3. Then I will make y the subject of the formula by simply making y to stand alone. So this becomes, so take 3 to the other side, we have x minus 3 equals to 2y. Then divide both sides by 2, divide this by 2, 2 cancel out 2. So y is simply equal to x minus 3 over 2. When is the second method useful? When you have multiple x's. So if you have a single x, then definitely you can still work with the first method. Okay, so let's look at how we can find the second inverse of the second function we are given. So let's look for the second inverse of the function we are given. So again, we try the first method. Try the first method. So you can say for number 2, the last thing we did was to divide by 4. The first thing what we did was square our x. So the first thing we want to do now, when we're looking for the function, so h inverse or the function of h, is simply for me to multiply by x. So I'll just do 4x, and then since I'm squaring here, I'll take the square root. So taking the square root, so let's try and put in the number here and see whether we have the same thing. So let's assume that x is equal to 2, x is equal to 2. So 2 squared over 4. So 2 squared is 4 over 4, and 4 over 4, this is equal to 1. So let me put 1 here and see whether I will have 2 back, 2 back. So where I'm starting from. So again, put 1 inside this. So 4 in the bracket of 1. So 4 times 1, that is 4, and square root of 4 is plus or negative 2. So take the positive value, and then we've arrived at where we're starting from. So I hope this makes sense for the first method. For the second method, what we simply want to do is to write the equation as equal to y, and then we solve from there. Okay, so let's say what we are saying. So again, we'll y is equal to h of x, okay, and then we say y is equal to x squared over 4. So interchange, write x as y and y as x, then make y the subject of the formula because multiply. So y squared is equal to 4x, and then what do we do to both sides? We take the square root of both sides. So square root cancel out square, so y is equal to square root of 4x. So these are the ways we can look for the inverse of a function. Now, lastly, we want to talk about the largest possible domain of function. Largest possible domain of function. So what this simply means is we're trying to look for a number we can put inside of the function that is not going to return a positive an output. What do I mean? If I were to have a machine and then I'm saying that no matter what the number you put inside of this machine, it will definitely return an output. Then definitely there'll be one number that you put in that instead of bringing an output, you'll be having an error. So that's what we're trying to look for, the largest possible domain of functions. Okay, so now when we have a linear function in such a way that the function is like this, so let's say we're given f of x is equal to 3x, sorry about that, so 3x plus 2. So the largest possible domain for this one is all real numbers ranging from negative integers to positive integers. In as much as they are real numbers, then definitely if I keep on putting them as value of x, I'll keep on having an output. So the largest possible domain of this one, we just say x is an element of all real numbers. Real numbers. So this one has no error. So no matter the value you put inside it, think of any number put inside of x, add it, multiply by 3 and add 2 to it, you still get what's it called, an output. Okay, so this is for the first one. So when we have what's it called, a linear function, how do we know it is linear? You can see that the power of the unknown here, you are saying it's 1. So this is a linear function. So it has this. Now what if we have a quadratic function? If we have a quadratic function, again, if you have a quadratic function, 3x to the power of 3 plus 2, sorry, I said 3x to the power of 3 should be 3x to the power of 2 plus 3. Again, no matter the value you put inside this function, definitely it's still going to be returning what's it called, an output. So basically we can say that, okay, in as much as we're not dealing with fractions, if we're not doing a fraction, whether it is linear, quadratic, cubic, to the fourth power, to the fifth power, no matter the values you put inside, x, the largest possible domain, will always be a function of all real numbers. So for the second one, we want to look at, so let's say we're given f of x is equal to 3x plus 2 and then over x plus 5. And then we're being asked to find the largest possible domain of this function. So what we simply want to do is to look for the largest number we can put, or the number we can put inside of this function that will make this function not to have an output. And how do we find that? Just take the denominator and equate it to 0. So while we're equating to 0, we know for a fraction, we can't divide anything by a fraction. It will give us an undefined answer. So how do we arrive at the denominator being 0? By simply taking the denominator x plus 5 and equating to 0. So solve for x will be equal to minus 5. So the largest possible domain of this is when x here is equal to negative 5. So if we're looking for what's it called? If we're looking for the largest possible domain, then we'll have to say that x must not be equal to negative 5. Then any other value we can put inside it will definitely return an answer. It doesn't matter, minus 25, minus 1 million, by the time you put it here and then you divide, you still have an output. So for a fraction, just simply take the denominator and equate it to 0 and then get the value of the unknown. So put your not equal to sign like this. This is the largest possible domain of this particular function. Now, lastly, for a root, so let's say we have something like this. F, sorry about that. Let's make it smaller. So f of x is equal to square root of 3x plus 2. Okay. Now, for this not to have any input, this what's it called, must be lesser than 0. So if it is less than 0, that means it's a negative number. If you press in your calculator, the square root of a negative number, you'll be having a complex or a math error. So an undefined value. So for this not to have any value, it must mean that 3x, sorry, let's write that properly, must mean that 3x plus 2 is less than 0. If you have to solve this inequality, we see that 3x is less than minus 2 and divide both sides by 3, so we have x is less than minus 2 over 3. So when we have a value that is less than minus 2 over 3, less than minus 2 over 3, then definitely, what's it called? This function will be undefined. So the largest possible domain will now be that x must be greater than or equal to negative 2 over 3. Otherwise, this returns 0. Everything inside here returns 0, and then the function would be undefined. All right, so this is everything we have for function. Remember, we started by talking about the meaning of mapping and function, where we looked at the types of mapping. We looked at the terms associated with mapping. We also looked at the function notation, how to substitute values inside of a function, and how to represent function. So we represent function using arrow diagrams, using equation, and using graphs. And then moving on, we talked about composite function. And lastly, we're talking about inverse function and largest possible domain of function. All right, so if this video has been helpful to you, so do well to share to your friends and like the video, subscribe to the channel so that you can get more or you can get notification of more videos that we drop that are helpful like this. Thank you and bye bye.